Welcome to EDU World Space.
So hey there, this is a relativistic addition problem. And so what you have is a lab uh, that is obviously at rest. There's the lab's reference frame, and two particles are created, each moving with equal and opposite velocities. So particle 1 is moving to the right, particle 2 is moving to the left, and we set the convention that the direction of motion of particle 1 right side is positive and the other side would be negative, right? So this is just a convention. We can flip this around and assuming we calculate everything correctly, we would get the same answer. So really your choice of reference frames is your own here because they don't specify which particle you want, which particle's velocity you want respect to which other one. So um, here we're choosing reference frame S prime to be particle 2, which is the negative direction, particle moving in the negative direction, and S to be particle 1, particle moving in a positive direction. So basically the velocity we're interested in is U, which is S, velocity of particle 1, velocity of particle 1 with respect to velocity of particle 2. And so V would be velocity of the lab with respect to particle 2, and U prime would be velocity of particle 1 with respect to the lab, right? So let's write that down. Relativistic addition of velocities is U equals V plus U prime over 1 plus VU prime over C squared. And so V, velocity of lab with respect to particle 2, this particle 2 is moving away in that direction. It sees the lab moving with its speed in that in the opposite direction. So you have V equals 0.82 C, and then U prime would just be U prime would just be the velocity of the positive moving particle, S particle 1 with respect to the lab. So this would obviously be plus 0.82 C. Okay, divided by 1 plus 0.82 C times 0.82 C, right, over C squared. And so your factors of C squared cancel here, and what you get is 1.64 C over 1.6724, which is very nearly 0.981 C, or about 98% of the speed of light. And so note again that if we had chosen different reference frames, assuming we choose the right velocities then to put in this equation, you would get an equivalent answer. So that's it.